My name is Steve O'Malley, lead engineering consultant with Efficiency Vermont. I work a lot with the commercial new construction program, as well as large multifamily new construction, and code is my hobby. So let's get into this. First thing I need to discuss here is that material contained here is proprietary to and copyrighted by ICC, and we have obtained and reproduced this information with their permission. The acronym ICC and their logo are trademarks and service marks of ICC. And here we go, additional efficiency, renewable and load management requirements. So to comply with this section, it's applying to buildings that are greater than 1,000 square feet. Let me back up for a second. Buildings that are greater than 1,000 square feet, you only need to comply with the additional energy credits requirement. But if you have a building greater than 2,500 square feet and gross floor area, then you need to comply with both the additional energy credit requirements and the new renewable and load management credit section. So looking at the energy efficiency credit requirements, how many points does my building need? You'll notice that this looks drastically different than the 2020 code. The 2020 CBES, all of these values were, if I remember correctly, single digits perhaps. And we'll get into it here. You'll see that there's actually a lot more options for points, and that the points that are awarded for the different measures has changed as well. But here we go, points by building occupancy group. And what about mixed occupancy? So calculate a weighted average of credit requirements based on the square footage of floor area. So I'm thinking about those mixed use buildings like commercial first floor and 3 stories of multi above, for instance. I'm not going to get into it here just because there's a lot of little subsections here, but just know that they're for core and shell buildings and build out construction. There is a little section in here that talks about how you comply with meeting this part of the code. So energy efficiency measures and credits. Here we go. We've got, I actually haven't added this up. It's over 20 different options for meeting this requirement, and we're just going to step right through them. So up first, envelope performance. Improved envelope performance, excuse me, for 90.1. Essentially, there's a formula that you use here to determine what are the number of energy credits that shall be determined. You'll see that in the table. I go back here for a second. You'll notice here in the table that by building occupancy group and then scrolling down through energy credit measures, you'll see that it looks to be a fixed number of credits that you will receive. It turns out that a number of these actually can be prorated or are based on a formula that the number that they're showing there ends up being sort of the maximum that you can get. And I'll be sure to point those out as we're going through this morning. So if you're going through the 90.1 basis for demonstrating code compliance, etc., just know that this is a way that you can get points for improved envelope performance. And obviously there's a little bit more to the section, but here's one of these cases where there's a formula that allows you to determine how many credits you're going to get. Okay, total UA envelope reduction. The U value of the entire thermal envelope needs to be 15% better than what's essentially in the prescriptive tables. I want to say anything more about that. I don't. Reduced air leakage. So the minimum requirement now for base code, and the only code, there is no stretch anymore, just regular old code, is 0.25 CFM 75 per square foot of exterior surface area. And here, to get these points for reduced air leakage, you need to hit 0.15 CFM per square foot. And it's interesting to me that it doesn't differentiate in the language there whether or not they're talking about CFM 50 or CFM 75. And that 50 or 75 refers to how many pascals of depressurization you're putting the building under. So my read on this is that if you've got a multifamily building, you're reducing air leakage to at a CFM 50 rate, and that for other commercial spaces it's CFM 75, and I'm basing that on what's written in the base code. Okay, roof insulation. So for a flat roof, you need to add an additional R10 continuous above what is already required in the prescriptive tables. If you have an attic, either the fill or the bat needs to be rated at R10, and they say, and that is continuous. So, I'm just envisioning that if you're up in your attic and you're looking down, you've already blown your attic to say R49 or R60, R49. I can't remember which one is base code. And then you would just be adding an additional R10 on top of that. But if your insulation was going to be interrupted, then they're saying to add to an additional R13, and that will meet the intent. And here's a case. If you only install an additional half of that R value, then you're going to get half of the credit that's shown there. So for instance, and I'll say that it's half of the credit rounded, and I can't remember if it's rounded up or rounded down. But for instance, if we look at adding roof insulation group R2, it will say you get 7 points if you do the full R10, but if you only did R5, it's going to say that you get half of that, which would be 3.5 credits. But that gets rounded. Adding wall insulation, 90% or more of the opaque wall area needs to be addressed if you're going to add additional insulation. And it needs to be an additional R5 continuous to that assembly. And similar to the roof, if you install half of this added R value, then you're going to get half of the base credit that's shown. Improved fenestrations, area weighted U factor of all vertical fenestrations less than or equal to U 0.22. We're starting to get into some rarefied air there. It's starting to look like triple pane windows to me at that point. Let's see, more efficient HVAC equipment performance. And please, if I'm going too fast for anybody, please just make a comment. There's not a lot to these, and there's a lot of them, so I'm just going to kind of be moving through them. More efficient HVAC equipment performance. So this is for systems using the TSPR, the total system performance ratio, and that TSPR, it needs to exceed the minimum TSPR requirement by 5%. See, more efficient HVAC equipment on the heating side. So equipment shall be 5% more efficient than the requirement. So again, we're thinking about those tables that are back in the base part of code. And here's a case where the formula, you can actually get more points than are shown there. So you get extra credit if you are more than 5% efficient, if your efficiency of your equipment is more than 5% greater than what's required by code. And there is a formula. I'm not going to show it here, but there's a formula in code that you would use to calculate that. And there is a caveat there that in the case of electric resistance heating, that the capacity is limited to 20% of system capacity. And it says the exception is that supplemental heating for heat pumps. And you'll notice on the table here, some of the areas are grayed out, and that's on purpose. That just is calling out the fact that there are some occupancy groups that cannot obtain energy credits for particular measures. So if we're looking back here at HVAC performance, we can see that occupancy group A2 and occupancy group S1 and S2 are not allowed to get any additional credits in that section. Okay, HVAC cooling equipment efficiency. Similar to on the heating side, equipment shall be 5% more efficient than what's required. And then again, an extra credit if you exceed that and select equipment that's more than 5% above baseline. And there's a note here that fan power shall be 95% of allowed fan power if fan energy is not included in the packaged equipment rating. Residential HVAC controls, as you can see, looking at the table, this one really is only applying for our R2, R4, and I1 occupancy groups. And so these residential HVAC controls would have an automatic setback of at least 5 degrees Fahrenheit on the heating and cooling side for dwelling and sleeping units. And there are several control strategies to select from. Again, if I look at my notes over here, I didn't put it in the slide because it was going to be way too much information, but I'll just read them because it's interesting that the various approaches that you can employ here. You can have a manual main control device by each dwelling unit main entrance that initiates setback in non-ventilation mode. You can have aux sensors in each room combined with door switch that initiates setback in non-ventilation mode within 20 minutes of all spaces being vacant immediately after a door switch operation. You can use advanced learning thermostat or controllers that recognizes occupant present and automatically creates a schedule and provides dynamic setback. And fourthly, you can use an automated control and sensing system that uses geographic fencing connected to the occupant's cell phone and initiates setback when occupants are away from the building. Okay, energy recovery. So this is, one of the caveat it called out was only for areas where single zone HVAC units are not required to have variable speed fan control. So if you meet that criteria, then the ERV that you're installing shall have 75% enthalpy recovery or 75% sensible recovery if no cooling. So that would be in the case of you put in an HRV if you didn't have any cooling in your building. There needs to be auto economizing. So essentially thinking about a rooftop unit here, that it's going to bring in cool outdoor air when conditions permit, meaning it's cold enough and it's not too humid. And that systems providing mechanical dehumidification, that the recovered energy is used for reheat. Yeah, so the next 5 that we're looking at in this table here, that I'll start with the W01 through W05. These are all related to hot water, and so let's just actually there's 9 of them because I could only show part of the table there before. There's a whole slew of measures that we can obtain these additional energy efficiency credits through hot water. And it seems like this hot water section, as I was going through, it's really broken into 3 sections. The first 2 there deal with system efficiency. The next 4 have to do with distribution temperature maintenance. And then the last 3 just sort of felt like a catch-all, so other. So we'll kind of go through these by section, I'll call it. Okay, so up till now, the whole credit table thing has been just very linear, meaning you select a measure. If a measure looked attractive to you in terms of something you wanted to obtain the credits for, you just did the measure, you get the credits, and you can add them any old measure to any old measure. We get into hot water and they start to make some distinctions about which ones you can combine and which ones you can't combine. And so that's what I want to highlight here. So under this reduced energy use for in-service water heating, you kind of have to pick one of these paths. So let's start off with, and if you're going to choose, if you were looking at, say, measure 1 or measure 2, because like, wow, there's a ton of points that I'm going to get for doing those things. Well, it actually calls right out of the gate. You have to pick one or the other. You can't do both of them. And then, so those are those 2 in the bright orange up at the top. Pick one of those. But you don't have to pick one of those because you don't have to pick any of these actually. You can get points from other sections. But if you're getting in the hot water, this is sort of how you have to think about it. Now the ones that are sort of highlighted here in blue, similarly, you can pick W04, W5, or W06. You just can't combine any of those. You can't do, for instance, W04 and 06. And then the other category, the ones that are highlighted there in sort of the pale yellow, you can pick any of those in any combination. You could have all four of them in your design if you wanted. And so those can all be combined, but they can be combined with either one or two above. I know it's a little nuts, but that's the way it is. So for instance, you could do, oh, I'm going to do all of these things. I'm going to do 3, 7, 8, 9, but then you could only pick, for instance, 01 or 02, or you could pick 04, 05, or 06 to accompany that. Clear as mud, I hope. But that is what the code says. So let's start talking about these individual measures here. The first one up, recovered or renewable water heating. So essentially meet 30% of annual hot water requirements by one of the following means. So waste heat recovery off of service hot water system or a heat recovery chiller, etc. Air to water heat pumps that pre-cool chilled water returns, on-site renewables. And then what was the last one here? Meet 70% of annual hot water requirements if required to comply with C403 10.5. And that's just getting back into base code. If you have to meet that, then it's saying meet 70% of annual hot water requirements of this section up above. Heat pump water heaters meet 30% of demand without backup at an ambient condition of 67.5 degrees Fahrenheit. If supplemental electric resistant heating is used, the heat pump capacity must be 40% of the first hour draw. And there are a host of other design related conditions. So again, I wouldn't put anybody through it to have that out there on a slide. So we'll just let you know that if you were going to if you're looking at heat pump water heaters as a way of getting some of these additional credits, that just know that you've got to spend some time looking through the design conditions for that. Okay, so we just covered W01 and W02, and if I back up, remember I told you we had to pick one or the other, but they throw in an exception for this, which says for combination service water heating systems, where they employ both O1 and O2, they may be combined and receive the sum of both credits. I know that flies in the face of what we said about having to pick one or two, but this is what the code says. Okay, keeping on here with service water heating, pipe insulation increase. So increase the insulation thickness by 1.5 times. The insulation shall be installed from the source to fixture shutoff. And here we go again with being able to prorate. So prorate credit if less than 50% of pipe insulation does not meet the 1.5 times requirement. So you can get partial points if you do a little bit less there. Point of use water heaters. So a handful of requirements for these. This is only for buildings greater than 10,000 square feet without recirculation systems or heat trace piping. 100% of the base pipe insulation requirements need to be met. So that means from the water heater to the fixture termination. And by 100% of the base pipe insulation requirements, I mean, we're talking about just code. What would code require? Not sort of what we were just talking about a second ago. There are some limits on how far away these units can be installed away from the fixture termination. So we'll see there that has to be less than 0.25 gallons of water in pipe in between the water heater and the termination of that fixture pipe. And then there was a little caveat here that talked about local recirc or heat trace piping allowed for separate water heaters that are serving commercial kitchens or showers and locker rooms. Okay, thermostatic balancing valves, TBVs. Each recirculation branch shall return, each recirc branch return shall have a thermostatic balancing valve set to minimal return water flow when return temperature is greater than 120 degrees Fahrenheit. So what we're getting at here is heat loss through the recirc system. Essentially it's like a big radiator in your building that is just emitting heat as you're sitting there and pumping hot water around and around your building. So if we can slow the flow of that down, there are some measurable energy savings to be had. So service water heating, heat trace systems. Again, building has to be greater than 10,000 square feet. This is for central water systems. The system installed needs to be self-regulating. So that means the electric heat cables, the connection kits, and electronic controls. And the heat trace system would be installed directly on the hot water supply pipes underneath the insulation. And essentially, you're essentially using a heat trace system to replace the standby loss versus essentially relying back on your water heater to do that. Water heating system submeters. So again, central domestic hot water systems. Dwelling units are provided with hot water meters connected to a reporting system, and it reports on what the actual domestic hot water consumption is on a per unit basis. Service hot water flow reduction, and here we're just talking low flow devices. Flow or consumption ratings less than, here we go, 1.5 or 1.2 GPM for sinks, your bathroom sinks, 1.5 GPM for your kitchen sinks, and 1.5 GPM for your shower heads. And that one gets a ton of points. I'm just looking here at those building occupancy groups, R1, all other, but 68 points there in group R2. So your multifamily buildings, just by doing this, you're gonna mop up a lot of points. And the last one in our service hot water category is shower drain heat recovery. And for those of you who might have seen this before, I think of products like the power pipe, which is it's a vertical section of copper piping that you would effectively just replace the drain pipe from the shower. They can come in length from 4 to 8 feet. And on the outside of it is a coil that is where the cold water feed that goes to the shower goes. And as you can picture, you're taking a hot shower, that hot water goes down the drain, and it doesn't just fall down the middle of the drain. It forms a thin film all around the 360 degrees around the inside of the perimeter of that uh, of that drain pipe. So you've got this nice warm water flowing down all of the copper pipe on the inside, and on the outside you have cold water coming in through that coil that's coiled tightly all the way around up that drain pipe, and it gives up its energy to it. And me being an energy nerd, I threw one of these in my house and played with it with an IR camera. And I have a short one; it's a 4-foot section, and it adds about 25 degrees to that incoming cold water just by going through that process. Just for those of you who are curious. Let's see here. The last bits here about shower drain heat recovery. Group E, if apparently for Group E, even though it shows that you don't get points for it in the table, there was a little caveat in the language that said that in Group E, if there were more than 8 showers, then you could qualify for the credits. And then partial credit for buildings where all but ground floor showers are served. So think slab on building. First floor, it's hard to put in a drain water heat recovery device there, but you could do it for the floors above. Okay, moving on from service hot water systems. Energy monitoring. Some buildings already have to comply with energy monitoring. So if you do, and that's in section C 405.12, if you already have to, then you cannot get any of these points. But then really all it says here is that if you want points for doing energy monitoring, comply with section C 405.12. And energy monitoring really is just looking, when I think back on what that section talks about, it's really covering everything. It's covering lighting, it's covering HVAC, plug loads, etc. And then being able to provide reporting it out to building maintenance staff, etc., or building operator. This whole next section that I've got circled over there on the left.
Hey,
this
Steve,
is all.
we do have a question.
Sure.
Go ahead, Walter.
Oh, you're muted, Walter.
You should be able to change that in the toolbar. There you go. All right.
I was under the impression that the PO1 for energy monitoring, those were actually the points that you might get if your building was smaller than those buildings that were required by code to do energy monitoring. In other words, above 25,000 square feet. So if you chose to do it and you had a building that was 20,000 square feet and it was one of these groups, you could qualify for those points.
Correct. Exactly. So any building that doesn't, I didn't word it so eloquently when I look at my slide here. That first little bullet at the top says for buildings not required to comply. So for all you listening, Walter's talking about the requirement is for buildings in code. It's written that it's buildings over 25,000 square feet have to do energy monitoring. So you can't get any points here if you're over 25,000 square feet and you have to do energy monitoring. And as Walter's pointing out, if you had a smaller building that's not required, that's where this applies. You can then, if you were to install energy monitoring at your building, then you can get these points.
So then the other question that I have is, given how expensive, in my mind, energy monitoring is to do, I'm thinking the average 25,000 square foot building is going to spend $80,000 or $100,000. How come there aren't more points here?
Great question. I don't know. Duly noted, though.
Thank you.
Thanks, Walter. Any other questions at the moment? All righty. I think we can go ahead.
All right. Okay, energy savings in lighting systems. This is sort of similar to what we saw in the service water heating section, that they will allow some combinations and not allow some combinations. So stepping down through what I was reading code, you can pick any one of these and you're fine. But if you start wanting to layer them and do combinations of these, it broke out that you could pick any combination of 3, 4, 5, and 6, or you could pick any combination of 2, 3, and 4. I don't know what the rationale behind all of it is. I haven't asked the question, nor did I try to spend time looking at it to determine it, but just please know that there's some language in there talking about how these can be layered and how they cannot be layered and to obtain the particular points. So let's get into it. Lighting performance, you'll notice that it is grayed out across the entire bandwidth there, and it just says reserved for future use. We'll see what the future use is someday. Enhanced digital lighting controls need to at least 50% of the gross floor area needs to comply. Lighting controls need to be located, scheduled, and operated for base code. It needs to be controlled by a DDC. The sequence of operations need to appear on construction drawings. There are high-end trim requirements, and these points can be prorated. Not a ton of points, so the prorated piece might not really play out for you, but just know that that's an option here. Increase in occupancy sensors must comply with all three of these items. There's a list of required spaces. There's 20 or 30 of them that were listed in code, so I'm not calling them out here, but if your spaces are on that list, or has to appear on that list, I should say, it needs to be configured so that there's a 10-minute turn off after occupants have left the space. And if lighting power reduced, not turned off, then it has to be reduced down to 20% of full power. Increase daylight area. For those of you who have done these calculations in the past, you just need to increase your daylight area by 5% more than the base code requirement. Residential light controls. So aux sensors, automatic full off. Let me back up for a second. So here are the things that it called out. So using occupancy sensors, automatic full off for common restrooms, common laundry rooms, storage rooms, and utility rooms. Dwelling units have main controls that turn off all lights in switched receptacles. And at a minimum, 2 switched receptacles are installed and they're identified so that the tenant knows which ones are being controlled. And so you could picture that you've got sort of a switch on your way out the door that you could say, okay, I'm going to hit this, and I know when I walk out the door, I've powered everything down. Reduce lighting power density. Requirement is 95% or less of LPD requirement for interior spaces. And group R1 and R2 for common areas. What did I want to say about that? Oh, just that the reduced LPD only applies to common areas for group R1 and R2, but there are requirements for the in-unit aspects. So for the fixtures that are used in the dwelling units, there needs to be, what is it, 80% lumen per watt. I'm not sure what I've got there. In-unit lamps, 90% lumen per watt. I guess that's an increase over what code requires. I'm going to have to write back to people on that one. I'll follow that up because I'm not sure I've got that in there correctly. But there is a requirement for the in-unit fixtures and lamps in terms of lumens per watt. And there is a formula here to determine the credits. So again, not putting that here, but just be aware that's one of those sections where you've got to do some math to figure out how many credits you're actually going to receive here. And then this other section, you can just pick any, you can combine them all together if you wanted. You could do none of them, but there are no limits on how these ones can be layered. So equipment elevator, this is only for buildings 3 stories or more. Elevators must meet energy efficiency class A for ISO 25745-2. And similar, there's a formula here that you'll need to use to determine if the equipment you have selected qualifies. Efficient commercial kitchen equipment, comply with the Vermont appliance efficiency standards. And then there's a few pieces of equipment that need to exceed those standards, and those are fryers, dishwashers, and ovens. And the performance levels need to be indicated on the construction, permit documents. So the efficiencies of these various pieces of equipment need to be called out ahead of time. Residential kitchen equipment, dishwashers, refrigerators, freezers shall meet Energy Star Most Efficient 2021 status. And you can prorate credits where only some units are equipped with both refrigerators and dishwashers. So I can picture some of these buildings where I see some of it's workforce housing, some of it's affordable. Sometimes the studios don't get a dishwasher, and the 1 bedrooms and 2 bedrooms have both refrigerators and dishwashers. So that'd be a case where you do some of that prorating. The last one is fault detection. And again, this is for projects that are not required to comply with fault detection already as part of just the regular code. And again, it just says if you elect to do fault detection, install fault detection and diagnostic system to monitor HVAC systems, and then comply with the base code, that 403.2.3. Pause for some water here. Okay, this is the part that's really brand new to all of us for this code cycle, is renewable and load management credit requirements. And its premise is very similar to what we just saw for the energy efficiency credit requirements, that based on building occupancy group, there's a certain number of credits you need to achieve. And there's a table that outlines what are the different measures that are available, and how many points you're going to get per occupancy group. And in the big picture, we're talking about load management credits here, or just load management in general. You can see I've highlighted a block of measures over there on the left. And essentially what it's really getting at is that we want the building to be able to respond to high short-term electric prices, or grid conditions, or peak building load conditions. And so having controls in place that can do setbacks around those events. So let's get into it. On-site renewable energy. To qualify, need to install 0.1 watts per gross square foot of floor area, or secure off-site renewable energy, and use a formula to determine the total credits available for your project. Lighting load management. So luminaires would have dimming ability and automatic load management tools, such that 75% of the building lighting the load could be reduced, and that load gets reduced by 20% or more, and for a period no longer than 15 minutes. And prorate credits based on a formula for projects where 50 to 75% of the fixtures are controlled, as opposed to 75% of the fixtures. HVAC load management, cooling and electric heating, excuse me. The controls would gradually increase or decrease the cooling or heating set point by 3 degrees Fahrenheit for a minimum of 3 hours, or reduce capacity to 60% of installed capacity during a peak event. And then for HVAC serving multiple zones with less than 75% outdoor air, the controls would reduce outdoor air by 30% during a peak event. So automated shading, we're talking about vertical fenestrations here. Or I should say fenestrations in general. So if you have exterior devices that are providing the shading, you need to reduce the solar heat gain by 50%. If you have interior shading devices, minimum solar reflectance of 0.5 will receive 40% of the credits. So when you look at the two of those, it's just saying that the exterior devices do a much better job of reducing the solar gain than the interior devices. And then a couple things that are applicable to both the exterior and interior devices: 90% of coverage of east, south, and west fenestration exposures. They're automatically controlled, and there's a manual override locked out during peak events. Electric energy storage. Automatically charged during non-peak periods, and then discharged automatically during peak events. a minimum capacity of 1.5 watt-hours per square foot of gross building area. The credits that are shown in the table are based on a storage system of 5 watt-hours per square foot. And the actual credits are based on a formula, but it's limited, meaning it's anywhere. So we've got that minimum of 1.5 watt-hour per square foot, but the maximum is a 15 watt-hour per square foot system. And again, there's a formula to help you determine how many credits you would get based on the size of your system installed. So cooling energy storage, automatically activate ice or chilled water storage during summer peak periods. And similarly, actual credits are based on a formula. Service water heating energy storage. So this is was talking about electric service water heating. So suspend water heating during peak periods. Either preheat water above 140 degrees, but you have to install tempering valves at delivery locations. Alternatively, you can provide additional storage capacity. And in this case, if you're doing more of a storage capacity, 1/3 of the credits are available where heat pump water heating is used. And that's just because heat pump water heaters are really efficient to begin with. Building thermal mass. So projects where 80% or more of floor area is unoccupied from 12 p.m. to 6 a.m. Actually, that should read 12 a.m. to 6 a.m. So again, I'll make a change in my slide, but again, I'm going to say it again. That's midnight to 6 a.m. Buildings unoccupied, or 80% of the floor area is unoccupied. And the requirements are install 10 pounds per square foot thermal mass per square foot of floor area. The mass can be located on a wall or a floor. Your HVAC system has to have an economizer and be equipped with variable or low speed fans. There has to be a night flush control. So thinking again, summertime, get nice cool air, and on those nights where it's not humid out, you can flush the building. And there's a contractual obligation for post-occupancy commissioning and control tuning. And here's a neat one in that, so insulation embodied carbon. This is the first time I feel like code has really gotten at the heart of what all these code changes are getting at is reduction in global warming potential. And here they're calling out, we can do that through how we build our buildings as well. And so you'd go about calculating global warming potential and intensity per square foot of floor area, including foundation, wall and roof insulation materials. And then the credits are determined by a formula. And the formula is right there in code, as is a material global warming potential table. So again, all the various insulation materials you can think of, they've all been assigned a global warming potential, and you can use that formula to calculate your insulation embodied carbon credit. And then last, additional electric infrastructure. As you can see, it only applies to Group R2, and they can obtain points through this section because they're not required to through the base code.
Steve, we do have a question.
Sure.
Go ahead, Walter.
Nope.
Okay, try that again. Here, CO1, the insulation embodied carbon. You do a calculation based on your information, but as I read the code, it says that I don't have to meet any specific standard. All I have to do is do the little chart to get those points. In other words, there's no required, there are certain numbers they would like you to get to, but you're not required to get to those numbers. All you have to do is do the chart to get the points.
I don't have that up in front of me. So you would complete the formula, do the math.
Yep.
You might not get all of the points that are shown here. but you will get, it's sort of, isn't it sort of like the proration thing?
Nope. It's
No proration here?
nothing. If you do the chart, that what they're trying to do is get people used to the idea of embedded carbon. And there frankly, where there was a lot of pushback about this particular item, and they felt that this was a good first start, doing it simply for the insulation of the building and not worrying about things like the concrete and the steel and all that other stuff. And they said, if you'll just do the formula, do the chart, get a result, you will get your points. Period. Yep.
Right. As long as the insulation has a lower embodied carbon, meaning I don't think you could use like XPS in the formula and then walk away and say, well, I'm gonna take my insulation embodied carbon credit.
I think you're wrong. I think you can use any insulation you want. I think the other part of this is what they're trying to do is say to you, if now that you've actually done the chart, you've done the work to figure out what kind of insulation you're currently using, and you can see what other choices there are, that you might consider changing your choice to reduce your number. I think that was the other part of it's like a little training program to get people to think about not using XPS and using some of the other choices instead. At least that's the way it was read to me, and that's the way I've created it in my little world, that you get those points even if you choose to use XPS, which is pretty awful stuff. So that's what I think is going on there. I mean, you might want to just check with Barry or one of the folk and have that discussion.
Yeah, no, I
Thanks.
appreciate that feedback because I hadn't gleaned that when I was putting this together yesterday. I'll
So,
go back.
so it turns out that for most people who are never going to do anything that's on this chart, the only points they're going to get for this part of this is, whatever happens to occur in CO1 after they've completed that report. So, and I don't know, it's not that difficult a job. The other thing that I would like to spend 2 seconds on is the one that talks about on-site renewable energy. If I had a 25,000 square foot building and you tell me I got to have 0.1 watts per square foot, I would have to have 2,500 watts of PV power, which is 2.5 kW. Well, 2.5 kW isn't going to do anything for the building, and is going to cost, I don't know, $4,000 or $5,000 a kW because of its size, and it didn't really do me any good. So what was the point of picking such a ridiculously low number? I mean, the typical building has between 0.3 and 0.4 watts a square foot for light. So why aren't we picking some number that makes sense so that we would at least cover doing renewables on the lighting? Just seems odd that you're getting that many points for that for doing nothing. That's what it boils down to, considering how few points are being given for energy, for the energy reporting system, which is going to cost a fortune to install. Thanks.
Yeah.
Thanks, Walter.
And I would say on that RO1, the on-site renewable energy, I don't think people would look at that and think, I'm going to go after those points I think I'll put on some PV. It's probably working the other way. People are probably already committed to doing PV, and then they're going to pick up those points. Because as you were pointing out, Walter, someone to install that small of a system and all the infrastructure, it wouldn't be cost effective for them to do that to try to get points for that section.
And also worth noting, Steve, I think that we are not the developers or the adopters of code. That is with the Public Service Department and goes through a variety of public notice and comment periods and through formal rulemaking. So we are simply providing the training as to what has been adopted, not why per se.
Right. Yeah. Yeah. This is, I joke, this isn't my day job. My day job is as an energy consultant And I need to know code because I'm working with design partners throughout the state, builders, owners, engineers, architects, etc. And so I'm doing this to educate myself and to provide training to our valued partners out there. So yeah, I didn't write this. Don't hold me accountable.
Valid questions, though. Thank you. Quick time check, Steve.
8:24. Okay, yeah, I think we're gonna be doing great here
Okay, great.
because we just got through that. And the last little bit I want to talk about is there are some exceptions. So we've just go back here. Here's this table. It says, you know, if we go back to that initial table that said how many points we need to achieve by building group, there are some exceptions to that. So for instance, if your building achieves an additional 70% of energy efficiency credits, then you only need to obtain 50% of the renewable and load management credit requirements. If your building achieved an additional 120% of the energy efficiency credits, then you don't have to do any of the renewable and load management credit requirements. And then as a reminder, so buildings that are smaller than 2,500 square feet do not need to achieve, excuse me, buildings between 1,000 and 2,500 square feet do not need to achieve any renewable and load management credits. They only have to comply with the energy credits requirement. And 4 minutes, we did it. So happy to take additional questions at this point. And if there are no more questions, then we all will start our days a little earlier today.
Thanks so much, Steve. We can hang on another minute or so here.
Sure.
And we have another comment or question from Walter. You should be able to unmute.
I do have another question. At the very beginning, when you were talking about the values that you could achieve through UA or U values or R values in your building, the first few credits under at the very beginning of the building, there is you indicated that the table provided numbers that are the maximum that you can achieve, and that's not quite really true. That's the number you can achieve as the standard, but if you exceed the code by, or let's just say that we're talking about the UA value of the building, and let's say that your UA value is 125% or above or below the number for the building, you can actually get that points value multiplied by some percentage, so that number, the 28, might actually turn for that particular line item. If let's say your building is 30% lower and the standard is 15, you can double that credit from 28 to 50. I think you can easily achieve a relative, if you're building a really decent building, you can achieve a pretty significant number of points in part one. And the other thing, I think you missed a slide, was that part two has its own points values. There's a slide that talks about what points you need to achieve for the various building types, and the part two build thing has its own little chart to tell you how many points you need, as opposed to the chart that's in number one. So there.
I'm not following that last bit about the part one and the part two.
Part one has its own little chart at the beginning that says you need to achieve these points.
Part one, are
Part-
you talking about energy efficiency credits or renewable
Yes.
load management?
Yeah,
So,
energy efficiency. Yeah,
right. So
that has its own little. Go to the very top and up down. You
yeah,
have the.
I'm getting
Oh,
there.
there you go.
Yeah.
So these are the energy credit one.
Yes.
Also a chart for the load management one that
Yeah.
has its own list.
Yeah. I thought I had that.
I didn't see it. You didn't show it.
Hang on.
Should be right above that
There
one.
it is.
Okay, there it is. Okay, yeah, I didn't see that. It shot
Yeah.
by me, I guess.
Okay.
Yes. So that has its own little list that you have
Correct.
to comply with.
Yeah. Correct.
And with that, I guess I'll just shut up. Thanks. Thank you very much, Steve. I appreciate it.
Yeah. Thank you, Walter. Appreciate your questions.
And certainly happy to go back and point that out.
Whoa.
Point that content out that might have been missed. So I think we'll wrap it up. We're right at 8:30. So